Hello, today I will be talking to you about sampling issues and options. So if we think about sampling, a sample is a group of people chosen to represent a larger sample of people. And as we think about exploratory studies versus more explanatory studies, in exploratory studies, the sample is chosen for its availability. And for explanatory studies, the sampling methods are utilized so that they can be generalizable. The learning objectives are to explain the relative importance of sampling in quantitative and qualitative research, differentiate between various probability sampling techniques, recognizing the strengths and weaknesses, and compare different non-probability sampling techniques and recognize situations in which these techniques are appropriate, and analyze the needs of a research study in order to select the most appropriate sampling techniques. So let's start off with some terminology related to sampling. So one of the terms is called case. The case is a basic unit of analysis in a research study, and it refers to many different units of analysis. For example, a family, a group, an organization, a community, even a nation, or of course, an individual. So in this example right here, we see that the universe would be all women in the US. The population of our study would be 1,000 women in the clinic, but our sample is specifically 200 women that will be part of our study. So sampling frame. So here, the population may be defined, for example, as all current BSW and MSW student at New Mexico State University. And the sampling frame is a list of all potential cases from which the sample is drawn. So in this case, it's a complete list of all items in my population. So it's a complete list of everyone that I want to study. And so sample is a subset of cases selected for study among people or objects within a targeted population. So for example, let's say that your population is every American because you wanted to find out how much the average person earns. But you choose only 1,000 random people. So this would be your sample. And representativeness refers to the degree to which a research sample is similar to the population from which it was withdrawn. Thus, representativeness should be regarded as a relative term. So ideally, we would like to study cases that are identical in all respects to the members of the populations from which they were selected. But of course, the only way to do that is if we study the entire population. But if we did that, it would be very difficult and very expensive to include everyone in the sample. But fortunately, we have or we can take into consideration representativeness because a sample can be sufficiently representative of a population if it resembles a population as a whole with respect to a limited number of relevant variables. So sample size basically refers to the numbers of cases the sample contains. And for quantitative studies, the larger the size, the more likely it is representative. And there are two principles that we need to consider. One, again, is the size of population from which the sample was drawn, and another one is the level of variability in the population. Sampling error. So because, for example, within samples of 15, for example, there's likely to be less sampling error with samples of, for example, only 5. So a sample of 5 might contain, for example, 5 of the oldest students in a classroom. If we're talking about maybe elementary school, then the sampling error might be large. But in sampling, for example, 15 students from a class, our first 5 selections might be the same 5 older students, but as we select more cases for the sample, the likelihood of drawing younger than average students would now be increased. So again, increasing sampling size decreases potential for sampling error. So sampling bias. So sampling bias can occur either intentionally or unintentionally. And basically what it means is that it is a systematic distortion of the sample. It could be overrepresentative or underrepresentative, and I will go over those terms shortly. And it may be unavoidable, and we need to control for conditions as much as possible. So what is happening here? It is showing you the difference between, or the process and difference between random selection and random assignment. So the first step is random selection, in which all the cases have the equal probability of being selected from the population, which means that increases sample representativeness. And the second step, you're doing random assignment. You're randomly assigning, the cases into 2 different groups, one the control, one the treatment. So this would happen in experimental conditions. So random sample. So random sample entails drawing the cases for a sample or subsample so that all the cases have an equal probability of being selected. So it is designed to prevent sampling bias. And again, random sampling should not be confused with random assignment. These two, again, can be confusing terms. But random selection is a process of randomly selecting cases from the population so that our sample is believed to be roughly equivalent to the larger population, and random assignment is a process of randomly assigning the cases to subgroups after they're selected from your sample. So let's go over probability sampling. So simple random sampling. So what this entails is selecting a predetermined a number of cases from the sampling frame or population. So for smaller populations, You can draw cases from a container, for example, with index cards identifying each member of the population. And for drawing larger populations, you can use a table or a computer generated list of mathematically generated random numbers to assist in the selection of cases. And simple random sampling is the most well-known type of probability sample, and it entails randomly selecting a predetermined number of cases from the sampling frame or population. So for example, if we wanted to select a 25% sample or 25 people from a sampling frame of 100, we could write each person's name on the individual card and then randomly select 25 cards from a container. So the next type of sampling, it's called systematic random sampling. And this type of sampling, you compute the necessary sampling interval, which is determined by dividing the number of cases in the sampling frame or population by the number of cases needed for the sample. So an example of this would be, for example, if you run an agency and you want to know your client's satisfaction, so you can do this by deciding, for example, to survey or interview every fifth visitor or client who leaves the agency every day for a week. So again, even though you do not have a list of clients ahead of time, this method can provide you with a representative sample of your clients, since their order of exit is essentially random. Okay, so stratified random sampling is a type of probability sampling using a research organization that can branch out the entire population into multiple non-overlapping homogeneous groups. And this helps to reduce the amount of sampling error and ensures enough cases within each different value. So the steps would be dividing the population into homogeneous categories. For example, gender, race, profession. And second, you would select the desired number of cases from each stratum by simple random sampling or systematic sampling. So let's consider, for example, in which the research team is seeking opinions about religion amongst various age groups. So instead of collecting feedback from all the US citizens, so random samples of around maybe 100,000 can be selected, and these 100,000 can be divided into different strata according to their ages. The advantages of using this type of sampling is that it can have or provide greater precision, than a simple random sample of the same size. And because it provides greater precision, it often requires a smaller sample, which can save money. Cluster sampling usually are used for large-scale surveys, and it involves a multi-stage process. Again, they're more likely to be used in large-scale surveys or studies that can involve cases that are geographically distant from each other. So first we identify clusters of cases, and next we randomly select a predetermined number of clusters, then all cases, or sometimes a random sample of all cases within each of the selected clusters, is selected to constitute the research sample. So let's look at an example. So if you need a random sample of people experiencing homelessness, but you have no list of people because this is a difficult to reach population, then you would gather a list of all shelters in an area, and each shelter is a cluster of cases. Then within those clusters, you would do the random sample. Again, so then the shelter selected would randomly select the persons in the shelter. So let's go over non-probability sampling. So in this non-probability sampling, you can use it when you cannot use random sampling. You cannot estimate the sampling error, and you can use it when no population list or sampling frame is possible. Again, this method should be used when it is difficult to use random selection. So convenience sampling, again, entails selecting cases for study primarily because they happen to be readily accessible to the researcher. So it is also called accidental sampling. It may produce an acceptable level of representativeness, but it is the method that is probably the least likely to do so. Purposive sampling, in this type of sampling, cases are not selected because researchers believe that cases can provide them with access to a unique approach to a problem or situation or a special perspective. They can provide a unique insight, expertise, experience, characteristics, or condition that they wish to understand. So you can use this in research in which, for example, purposive sampling might actually be preferable than a more representative one. So snowball sampling is a type of sampling in which one or just a few people are identified as potential research participants, and they are asked to provide the names of people they know or know about who, like themselves, have experienced a problem or who in other ways meet the necessary criteria for inclusion in the research study. So the next potential participants then are contacted to determine whether they are eligible for inclusion in the same sample, and if so, whether they are willing to participate in the study. They may in return be asked to provide the names of other potential participants. So the process is repeated until enough participants are eligible and agree to take part of the study. And again, so this may be a good sampling technique when you're working with hard to reach populations or when the problem or behavior is illegal or carries a social stigma, and it is used in exploratory studies. So quota sampling begins with estimating the characteristics of the research population regarding selected variables. Again, similar to the other one, it could be to gender, ethnicity. So this description is built into a matrix or table that displays the percentage of people in the population believed to share each combination of characteristics. So in proportional quota sampling, people are selected for study until the correct proportion of cases have the characteristics described within each cell of the matrix. And in non-proportional quota sampling, the minimum number of cases required for each category or combination or characteristics is determined, and sampling continues until the minimums are attained. So some tips on selecting a good sample. So it depends, one, on the available resources you have for securing the sample. So we know that large samples are costly. So if you have to have the funding in order to have larger samples. So in addition, the overall design and purpose of the study will dictate the type of sampling that needs to be used. So as we have said before, so you need to understand, so what kind of design do you want to use? Are you using more of a explanatory or exploratory study design? Are you, is very little known about the study, and you're working with a hard to reach population? Or are you wanting to do more of an explanatory study because there's already enough known about the subject and you're working more with a representative population? You also need to understand the type of statistical analysis, so that will dictate the size and sampling method. So again, if you're doing a quantitative study and you're using quantitative analysis, the sample size needs to be larger. And the relative importance of sample representativeness depends on whether you're doing a qualitative versus a quantitative study. Well, thank you so much. I hope you learned more about sampling techniques and which ones might be more appropriate for different types of study.